in this video, this is the video of week March 23rd. So this would be the video for Monday, March 23rd, 2020. So March 23rd, 2020 for ITS 372, and this would be on the topic of the file system. So in this video, I will go over basically just some definitions of the UNIX file system. So we're going to talk about the UNIX file system. All right, in particular, there's really just one concept that we have to understand there. So we want to understand the basic concept of the file system. And then after that, we want to go over some of the commands associated with this. And then finally, we will do an exercise in the form of a lab on file system analysis. So this will be what you will do, your homework basically for this week. So the homework of March 25th, you will be working on a lab on file system analysis that I will describe. So in essence, so the original UNIX file system dates back to the early days of UNIX. And it's really amazing that those original concepts of UNIX are still valid today. There have been obviously many improvements over the course of time, but the fundamental design of it, remains. So, for instance, if we take the example of Windows, originally Windows was designed as a system made up of drives. You'd have a C drive, then you have a D drive, then you have an E drive, and so on, right? So this was the original idea. On the other hand, Unix has a different, sort of an abstraction. So Unix, has an abstraction which all revolves around something called the file system. It is important to note that the original design, from around 1974 by Dennis Ritchie, right? So Ritchie, still, those original ideas stand, and Ritchie even though he hasn't, he's not one of the big recognized names like Steve Jobs or Bill Gates, he is very, very important for the development of the Unix operating system. And in particular, these ideas in his document of 1974 about the file system. Anyway, so basically, if you think of Unix, you want to really think about a single tree structure, right? So that's really the idea. So there's a single tree structure, as opposed to possibly individual forests, etc., that might exist in other, or individual tree structures that may exist in other operating systems. So if we think of the Unix file organization, so if we think of the Unix file organization, we can say that all Unix file systems all Unix file systems are organized within a single tree structure. Now this is an important concept, right? Because it indicates that there's one single level of abstraction, one single tree, and then everything connects to that tree. Every single aspect of Unix is represented as a file, which becomes a node in this tree. And this, so all Unix file systems are organized within a single tree structure underneath one root directory. And I think, during the class we've talked a lot about this. Remember, whenever you're in the prompt and the command line and you do something like cd, that symbol / right, that indicates that you are going to move directly to the root directory. So really the root directory is that /. So basically we can say now that slash, basically that /, if you just have the one, it indicates the root directory, but it also acts as basically separators for when you have multiple leaves or nodes in a tree, which are basically files or directories. So we can say that the leaves or nodes in the tree, leaves or nodes in the tree, are separated by slashes. Are separated by slashes. And so this is the example when you have, root, and then you have home, right? And then you have user, and then in here you'll have multiple folders like mail or something like that. So at the end of the day, this ends up converting into home u / mail. Okay. So basically we can say that, there's only one tree and there is no forest of directory trees. All right. So in Unix, there is no forest. So there is no forest of directory trees. There is no forest of directory trees, that begin with a specific, drive, such as, as I said, C drive or something like that. Okay. So everything, everything has to belong to that directory tree. So in order to make files on a disk partition accessible, the disk partition has to be mounted. So in order to make files on a disk partition accessible, the disk partition has to be mounted. Now, mounting, this idea of, so let me just write this correctly. So it has to be mounted. This is an important concept in Unix, all right? This idea of mounting something. So basically imagine that you have something like this. So you have, something, a disk, home, which has foo and bar, and then it has mail. Right? And so those are some files that you have accessible, or directories in a disk partition. Now you want to make them available in another computer, in another Unix system. So this disk partition has to be mounted on something else. So now you have another directory tree with a root, and then maybe you have something like dev, and then you have tty or something like that. But now within this file system, you will have to basically link this, right? You have, and that process is called mounting. So it'll have to be mounted on there. Okay, so that's the basic idea. So in order to make files on a disk partition accessible, the disk partition has to be mounted on a specific place. So the has to be mounted at some directory in the file system tree. So it has to be mounted at some directory in the file system tree. System tree. And basically this is, if you want to, in simple terms, now we could go in depth into the operating system itself, and we could look at specific types of, we could look at different file system types, operating system types, and we can look at acronyms like FFS, XFS, UFS, extended 2FS, and so on. But we're not getting into that level of detail in the operating system for this course. This is not an operating systems class, so our understanding just revolves around the system administration side of Unix. And so, as I indicated initially, the basic goal is to understand the basic concept of the file system. Okay, the basic concept of the file system, it's basically an abstraction of a single tree structure, and all Unix file systems or partitions are organized within a single tree structure underneath one root directory. Okay, so the leaves or nodes in the tree are separated by slashes. As you can see in this slide, there's no forest or directory trees made up of drives, and basically, in order to make files on a disk partition accessible, the disk partition has to be mounted at some directory in the file system, so as indicated. So that's really the main concept in Unix. Okay, so once we understand that, you pretty much understand how to organize files in Unix. Now, it's important to say that this is made in such a way that really different types of, imagine you have a Unix file system, right? Such as this one, etc. Different kinds of file systems could be added here in theory. So you could have a Windows partition, right? Or you could have a Mac, Apple partition, and in theory you can mount them on the file system, right? So probably on different points. But what's important to note here is that although they can be mounted in theory, they may not have the same, they may not have all the same metadata, if you will. So some of the information from the Windows or the Mac side may be lost, but at the same time, a lot of the information would also remain. So it is possible, although some information may be lost. So in essence, you can say that you may mount many different types of file systems on top of each other. So not only Unix standards, but also those accessed, across the network or from completely different vendors such as Microsoft, or Macintosh. Okay, so now that we've talked about the main concept of Unix, and hopefully that's clear, and this should become a little bit more clear as we start talking about the lab, and the goal of will be basically to have, you know, 2 disk partitions, you know, a file system, and to annex 1 disk partition from a separate machine into the file system of another machine. All right, so, but before we get to that, I also want to go over just a brief description of the different types of folders that you can have available in the file system. So let's move on to the next slide, and let's just talk about, you know, let's call this folders available in a Unix directory tree. So, you know, this may change from version to version of Unix. Some, you know, some types, Linux or Red Hat, will have different types of folders, but in essence, they usually have, you know, the following. So, you know, usually they, you know, these are the more common ones. So you'll have like the bin folder, and you'll have a dev folder, and then you'll have an etc folder. You will also have a home folder. Additionally, you may have a lib folder. You'll have, you know, you can usually have a mount folder as well. You can have a opt folder, have a proc folder, and so on. So there may be many others. You know, usually one that we always see is the temp folder. And then also folders like user and var. Okay, so basically in the next, in this discussion, in the next few slides, I will talk about some of these individual folders and just provide, you know, kind of a description of what they are, you know, and what kind of data is stored in these folders. Oops. Add a few more slides here. All right. All right, so let's talk about the bin folder. Let's talk about bin. All right, so this folder, this is the traditional location for executable files. So this is, you know, for executable files. So I would say, you know, if you want to make a reference to like Windows, this is the, you know, all programs type of folder. So this is where you have all the executables, all the little programs that will run in your Unix system. And this can be for, you know, programs that you have, but also where you have commands. Remember that a command usually is nothing more than an executable script. So commands and the utilities that are available. So utilities that are available on Unix as well. Right, so that's really what that is for. Another important folder is the dev folder. All right, so this usually should stand for the device directory. The device directory. Remember that even things like keyboards, you know, disks themselves, tape drives, terminals, etc., you know, at the end of the day, all of those become files. So everything in Unix is a file. That's the Linux way or the Unix way. And if everything is a file, all of those are abstracted as individual files. So if you want to have them accessible to your computer, they're going to be tied somehow into the file system under the dev folder. So this is for devices such as, your disks, terminals, keyboards and so on, and, even, tape drives, whatever you would have available. Another directory is the etc directory. So this is one folder that we've discussed in the class a lot, right? Because this is an important folder whenever we're doing configuration. So as this is a system administration class, a lot of what we do is just, configuring programs, and we have to look into the etc folder for files, text files that have to be modified. So usually this is, referred to as the system configuration file. So we can say config files. Okay, so these are the system configuration files, and also executables, and some executables. And executables. This contains a directory called the initd directory. So that one is located, should be located there. It's a subdirectory which has the system boot script. So whenever the Unix system initializes, historically, the init.d folder, so init.d, which is a subdirectory of etc, would contain the system boot scripts. And these boot scripts, they're nothing more than just plain text, batch files, etc. that run. They configure lots of things, the settings for the firewall, the settings for the network, the settings for the computer itself, and so on. All right, the next folder that we can look at is the home folder. So this should be familiar for you from the user account management lab. Basically, this folder contains the user's home directories. So the user's home directories. All right, so that's what's contained in there. And this is, so, you have something like home, seed, for instance, for the seed VM, and then there's like desktop. Right, and all the other things that a user will have. So that's the folder that contains that information. Whenever you learn in the previous user account management lab that whenever you created a user, a home folder was also created for that user. All right, the next folder that we can look at, let's move on to another slide. So the next one that we can look at is the lib folder. Lib folder, so that's another one. This could be a folder which is a location. It's a location for shared files. For shared files. And these can be required for booting the system. Sometimes, like I would say like the equivalent of this is something like the DLL files that you see in other operating systems, right? So basically it's, shared libraries that you need to be able to execute code in your system. All right, some computers have a opt folder, which stands for optional. Right, so this is, software that you don't necessarily need to have in the Unix operating system, but it's just optional, it says software. So these are, as you start deviating from version to version, you'll find that different versions will have different, somewhat odd folders where they keep, different kinds of information. Now there is one, the next folder is actually interesting, quite interesting, is the Proc folder. The Proc, PROC, or also known as the process directory. Process directory. Okay. Now this is an important one because it helps. Basically, the process directory is used for the kernel system. So it's used, I would say, in relation to the kernel system. So what happens is that sometimes, in the operating system, there's different levels of abstraction. So there's basically a very low level, which is the kernel of the operating system. And then on top of that, you have programs that we can execute, right? We have scripts and things like that that are running above. Now, anything that runs in the kernel, any software, so whenever you have something, you have the kernel is itself code, right? So it's code that's compiled. And whenever you have the kernel running, you can say that that's a very efficient piece of code. But you can't always predefine what the kernel will be, compile it, and then run it. There are times when you need to pass information to the kernel from the outside, right? So from outside the kernel, so that this is compiled code, but this is information that is still outside. So usually that's what the proc folder is for. So it's designed to enable processes to be manipulated using UNIX file access information or file system information. So the proc is really for that purpose. So imagine that, for instance, a classic example of this is when you're in the kernel, you're using the networking connections, right? The networking pipes, and you want to build a firewall. So you would definitely want the firewall code to be in the kernel, accessing the network traffic directly, but the rules of the firewall, the ACLs, right, need to be defined and changed outside. So usually you would want to have these ACLs outside in the proc folder and then have the kernel read this folder. So that's really the purpose of this folder. So it's the process directory designed to enable processes in the kernel to be manipulated through files in the file system. It's basically that helps to configure processes running in the kernel system. So I would say a good definition of this is that the proc folder holds files that can help to configure processes running in the kernel. In the kernel system itself. Right, so it's a good way of putting it. The proc folder is linked to the directory tree, but it has special access into the kernel itself, so you can set up, for instance, like rules, ACLs that would be passed to code in the kernel itself. Now, one common folder that we should be familiar with this semester is the temp folder. So this is the temporary directory. This is the temporary directory. Okay, and basically for temporary files. Now, things to remember: everything here gets deleted. on restart or when you turn off the system. So on system restart. So usually what happens is sometimes you have a program that downloads some files, some temporary information that it needs, that is needed for the program to run. So usually those files are downloaded to this temporary folder, but the moment that the program that the computer turns off, those files are deleted. All right, and a couple more folders that are important in the file system. We have a folder called user. So this contains subdirectories, for individual user. It's a subdirectory for individual user and admin commands, for instance, or individual files. So, basically it's another place where you can store programs and executables. Programs and executables, that are basically user specific. Finally, the last folder that we will look at is an important one called the var folder. Basically, the definition of this is that it's a subdirectory or folder for storing data. But basically, it stores data that varies quite a bit. So it's basically for data that varies. Data that varies, right? So that's really the objective of the var folder. It is for data that varies. And this, examples of this are plenty. So we have, for instance, we know that var there's a var www, and this contains, your websites, right? So this is the location in the Unix operating system of your websites. It's also used heavily, and we've used it in the class for logs. We know that there's, var logs, all that, everything that's recorded in the system related to operations, etc., are stored there. This is also a place where you have your mailboxes, so you have your mail information, or if you have a print server and you're going to send printing information, you would store the data here as well. So printing and various other things. So in essence, anything data that varies, that's really what the var folder is for. All right, so now that we've talked about the directory tree, we can kind of take a look at it again. So remember that in Unix, the file system kind of looks like this. All right, and then you might have all of those individual folders that we just mentioned. So home, etc, right? And then we have bin, but we also have user, right? And we have var, and so on, right? So, and then in here, remember, you'll have user, and then you have seed, for instance, for the seed VM, and then this is divided into, desktop, and then you have over here documents, let's say, and so on, right? So that's really, what the file system is for. Now, let's say that we had another partition over here, maybe another root system with its own bin and its own home, var, and so on. We have maybe another disk, another partition. This is one on a specific computer. Now, this computer, let's call this computer 1. This is computer 2. What we've learned so far about the architecture and the distribution of the folders, plus the main concept that Unix, everything is really just one single file system, and we know about mounting, is that we can create an access point. Let's say over here we create an access point, and then we could basically, through a process of mounting, create a connection so that this entire disk, let's call it, disk 3 something, could be mounted and become part of the file system for computer 1. So in essence now, if we want to navigate through this information here, right, we can do so just by, on this computer on C1, just accessing the file system and looking at this this folder now. We can call this, mount, right? And basically that means that is a mounted element that we have there. And now once we're in mount, we can, run commands like ls, etc., to look at the contents of this new disk. So that's really what we have learned so far. We've talked about the main concept. So if we go back to the original, at the start of the slides, we saw the main concept of the file system, which is this one, and then we saw, we saw the organization of the file system, and then now we're ready to look at a few commands related to the file system. Okay, so we're gonna move on to the next slide here. All right, so now under this section, we're gonna just explore a few additional concepts. So file system, oops, concepts or commands. All right, so we will explore this idea. So one of the main commands that we've learned in the terminal is that we can type something like ls-l or ls-a, right? And these are commands that allow us to do directory listing. We also learn the command cd, which allows us to basically navigate through the file system. Now, one thing that we sometimes do is we type ... or we type a dot like that, and it's not always clear that these are actually separate entities. So the dot and the ... they are actually, if you want to think of them as keywords. So the dot is keyword, and then the ... is a keyword itself. So each one of these has meaning. So the meaning of the dot is that this is a current directory. Right, so that's really what that means. That's why we don't usually use it, because we're there in that folder, although there are applications for it when you're specifying full paths, etc. But especially like when you're doing web development and you want to specify paths in the directory tree of the website. So that's when this becomes relevant, the current directory. In our purpose, we don't usually use it as much as, say, the 2 dots. Now, the 2 dots are a keyword, basically, that when we type on the terminal has a meaning. And the meaning is that the ... refers to the directory. It refers to the directory one level up or above. So one level up or above. So basically what happens is, you might be, you're here, you type pwd, and then you say, it'll say something like home user, right? And then if you do cd ... and then now you type pwd again, you're going to end up in home. All right, so that's basically what that means. The directory just indicates one level up. So by doing cd ... you're telling it to go one level up. All right, and so that's kind of an important concept. Another concept that's important when you're talking about the file system is symbolic links. All right, so we'll talk about symbolic links. Okay, so symbolic links are basically files as well, right? Because everything is a file in Unix. Their definition, though, is that they are a pointer. They are a pointer, or sometimes referred to as an alias. So a pointer or an alias to another file. To another file. But they are still technically, this pointer is still a file, it's just not, it's just a file that refers to another file. So basically, we can use symbolic links. So imagine, for instance, that we have a file called, let's say we have a file, we do ls, and then we have a file in there called check server 1.py. So we have that file, right? And now we want to create a symbolic link. So we do ln-s. All right, ln-s, and then we specify, so this tells us that we want to create a symbolic link between the actual file check server 1.py and a new alias. Let's call it Purdue. All right, so if we do that, then now we've created a symbolic link. So if we do, you know, the command, let's say ls-l, it's now going to show us a symbolic link, so all the information, and it's going to say Purdue. And by the way, Purdue is a symbolic link to check server 1.py. All right, so in essence, if we want to run this code, if we wanted to actually use the symbolic link, all we have to do is let's say we're in the terminal and we type Python, and now we can just call Purdue. And by doing that, Purdue itself will end up running the check server program. So in essence, we run our Python script. All right, so that is basically the definition of symbolic links and an example of how they work. Another concept that, whenever we looked at the file system, we've talked about changing ownership, right? So we talked about ownership. Ownership of files. We looked at two programs, chown, and we also looked at chgroup. However, one concept that we never really discussed so far is the concept of SetUID. Right, so SetUID is a file-specific concept, and this is important when, it's an important, I always call it an important workaround to the access control in Unix. All right, so SetUID, first of all, you can set a file to, excuse me, to be SetUID by running the command chmod 4000, and then let's say file, or chmod u+s file. All right, so that is the syntax that we can use to set a file to be SetUID. Okay, so basically the objective of this is that we're going to make a file become SetUID. So usually you'd have the file and you look at the permissions and it'll say read, write, execute, right? But once we set the file to be SetUID, it'll have parameters that say read, write, and there's going to be an S bit, And that basically just transforms a file to still be executable, but now it has additional behavior. Okay, so that's an important thing to note. So the definition of SetUID then is that for executable files, the SetUID command tells UNIX that regardless of who runs the program should be executed with the permissions of the owner. Okay, so that's really the definition of SetUID. So for executable files, the SetUID command tells UNIX to run the executable file with the permissions of the owner. So keep this in mind. This is important. It doesn't run with the permissions of whomever is executing the program. It runs with the permissions of the owner. So first of all, let's say you have a file that is root. So let's say I have a file passwd, right? A little, .exe, let's say. Keep it to make it obvious. The owner of this file is root. And the permissions are read, write, and SetUID. So basically now we go to the terminal and then you have a regular user. You're logged in as seed, let's say. So you're seed. But when you run this program, /passwd.exe, the instance that will be created in memory will not have the effective ID of seed. Instead, it'll have the effective ID of root, which basically means that for the operating system, for Unix itself, passwd will be running with the permissions of root, even though it is currently being executed as seed. So that is the definition of SetUID. So I'll repeat, for executable files, the SetUID bit tells Unix that regardless of who runs the program, it should be executed with the permissions of the owner of the file. So why is this relevant or important? So SetUID is important because there are access control basically works really well. But there are situations where access control does not really work for that particular scenario. So for instance, the classic scenario of this is we have, let's say we want to change a password, right? So I need to change, my password. I need to change my password. So my password needs to be changed for seed. So I want to do that, okay, and there's a little program called passwd.exe, let's say. So if I was to run this program, I could access this file and then change my password, and great, everything's done. The problem is that this file, the file that contains the passwords, is owned by root. So basically, when I run this program, I'm going to be seed, a regular user. I try to run this program. I try to access a file that is owned by root, and I will not be given permission to do that. So therefore, I need to find another way. But access control says that this file is owned by root and only root can modify. So a way to get around that is to make this program SetUID, because this program will be owned by root. And therefore, when seed runs the program, because it is SetUID, the program will run with the permissions of root, and then therefore be able, within the constraints of the program, be able to modify the password of seed and only seed. Keep in mind, this program here will be designed in such a way, or has to be designed in such a way, that is only allowed to change within this file the password for the ID of the person that is running it. All right, this concludes this set of slides, or this video. I want to keep the videos not too big, so I will continue our discussion for this week in another video.